Today's lesson is going to be on volume of prisms and cylinders. So go ahead and open up your textbook to page 925, and we'll start this lesson. So first of all, let's get some understanding of what a prism is. A prism is a solid with any shape base that keeps its same shape from top to bottom. So for example, the base of this prism is a rectangle and the top is exactly the same. So a prism always has two parallel bases that are identical. For example, we could also make this one would be a rectangular prism because the bases are rectangles, but you can also make a triangular prism if you make the bases both triangles like this. If I make the base on the bottom and the base on the top exactly the same, connect the sides, I now have a triangular prism. So this one would be a rectangular prism. This one would be a triangular prism. So you name the prisms according to their bases. And again, I want to emphasize that you can tell which ones are the bases because it's the two sides that are exactly the same and parallel. So those are the two parallel bases that you'll see for every prism. A cylinder is kind of like a prism. It has congruent bases that are also parallel. So this circle on the top and this circle on the bottom are both congruent figures, but they're not polygons. They're not rectangles, triangles, hexagons, trapezoids, any of those shapes. So since the base isn't made from straight edges, it's made from curved edges, we give it a different name. So it's a cylinder is just like a prism, except that its bases are circles. Okay, so cylinders and prisms are really the same idea. They both have two parallel bases that are congruent. So what we're going to look at is how to find the volume of prisms and cylinders, and they're going to give you, the book is going to give you a bunch of specific formulas for finding these volumes, and I really want to discourage you from using those. We don't need a different formula for each of these shapes. We're going to use the same volume formula for all of the shapes that we're going to learn today, and that is volume is equal to, I'll write it here for both of these, volume is equal to base area times height. And so we can abbreviate that V equals base area. We always use a capital B and then H for height. And so for this rectangular prism, our base is this rectangle. So the base area would be width times length. And so then our volume is going to be width time, it's going to be base area times height, and that's going to be width times the length times height. Okay, but this is really the and rather than memorizing 5 or 6 different formulas, we can use one formula here: volume equals base area times height. And so we don't need this special formula they gave us for a square prism or a cube. We can still just do volume equals base area times height. And so the base of the base area here would be S times S, or S squared, and then the height is also S. So we'd get volume equals base area times height. That's going to be S squared times S, which is S cubed. Okay, so it all comes from this formula: volume equals base area times height. Here are some composite figures that are made from cubes that each have a volume of 8 cubic centimeters. So to find the volume of a figure, all we have to do is count how many cubes it takes. And the purpose of these examples is just to help you understand that all volumes are made by determining how many three-dimensional cubes can fit inside them, or how many it takes to build them. And so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 cubes that make up this figure. So the volume is going to be 11 times 8, or 88 cubic units. Okay, go ahead and try problem 5. Press pause on your video, work out your example or work out your answer to problem number 5, and then press play when you're ready to see it. So the volume for this one, it takes 1, 2, 3, 4, 5, 6, 7, 8, 9 cubes. And it says here that each cube has a side of 2K. So if our sides are all 2K, we have 2K times 2K times 2K. So the volume of this cube, the volume of one cube is going to be base area 2K times 2K. That's our base area, times the height, which is also 2K. And so we get 8K cubed. 2 times 2 times 2 is 8. K times K times K is K cubed. So the volume of one cube is 8K cubed. We have 9 of those all together. So 9 times 8K cubed is 72K cubed for our volume. Next, we're going to see that the volume for oblique figures, oblique means they're tilted slightly to the side. So if you take a right prism, which means it stands straight up perpendicular to the ground, and you take an oblique prism, they both still have the volume in both cases is still volume equals base area times height. So it doesn't matter if it's slanted, as long as your height is perpendicular to the ground, the volume is still going to be volume equals base area times height. And so for this example, they tell us that the height of the cylinder is 3 times that of its radius. Okay, and so perpendicular to the ground is equal to 3r. And so since the base area is 81, we know the area of a circle is pi r squared. So 81 pi equals pi r squared. Divide both sides by pi, and then take the square root. You get r equals 9. So we know that our height is 27. And so now we can say volume equals base area times height. Base area they gave us is 81 pi, and the height is 27. And so if we do 81 times 27, we get 2187, and then times pi. That gives us 2 answers. So this is 2187 pi, and approximated as a decimal, that is 6870.7 cubic centimeters. So we can write centimeters cubed like that. So both answers are important. I would like you to be able to write the answers in exact form, so that's in terms of pi. And then this is an approximation. So try to get in the habit of doing that with every problem. Write an exact answer in terms of pi that's not rounded anywhere, and then a rounded answer is also helpful. Okay, so for all solids that we're looking at, doesn't matter if it's a cylinder or an oblique cylinder or an oblique prism, for all of them, the volume is always equal to base area times height. So you can add cylinder to your list here. The volume of a cylinder is equal to base area times height. So this works for this, this, and this. Okay, on page 929, go ahead and try problems 6 and 7. Press pause on your video, and when you're done with problems 6 and 7, press play and compare your solution to mine. For problem number 6, our volume is our base area times our height. Our base area, since this is a circle with a radius of 12, the base area is going to be pi r squared, so pi times 12 squared. Our base area is 144 pi. Our height is given as 45, so times 45. And so our answers, we're going to have 144 times 45. So notice that I typed in everything except for the pi. That's going to give me my answer of 6,480 pi. And then we also want to approximate that. So we'll just say times pi. And we get 20,357.5. And that's in cubic inches. For problem number 7, volume is also base area times height. And the base area is 20x squared, because it's 5x times 4x is 20x squared. So that's our base area. And then our height is x plus 2. And so if we multiply that out, we get 20x cubed plus 40x squared for our volume. And this one is actually in cubic centimeters. Okay, so now I've got some more examples for you. You'll probably need to take out another piece of paper because these ones are not in the textbook. So let's go ahead and find the volume of these figures. We'll do them 2 at a time. So copy these 2 problems down. Go ahead and find their volumes by doing volume equals base area times height. So press pause on your video, find the volume of those 2 figures, and then come on back and press play and you'll see the solutions. All right, for problem A, our base area is 6 and our height is 4, and so our volume is base area times height, so that's 6 times 4, which is 24 cubic feet. Okay. For problem B, I didn't put units on there, so I'm going to go ahead and add units in: 6 feet, 8 feet, 5 feet. And one thing that's tricky about this one is figuring out what your base is. Normally, we have, for most of the figures we've looked at so far, the base was the bottom. But in this case, this cannot be our base, because for a prism, the base, it has to have two bases that are parallel and the same figure, and we don't have that in this case. So what we need to realize is that this figure is not sitting on its base. The bases are actually these two triangles. And so if we could pick up this figure, we could actually tip it over and make it sit on its two bases. If we did that, it might look like this. So we would sit it on that triangular face, and so it would look like that if I set the triangle on the two bases. So it would look like this. There's our right angle, and then we have 6 and 8 and 5. So you could redraw it like that if that helps you, or if you want to leave it the way it originally was, it doesn't matter, as long as you recognize that these two parallel triangles are the two bases. So the base area for this one is the area of a triangle, and that is 1/2 base times height. So that's 1/2 6 times 8. And so that's 24. 1/2 of 48 is 24. And so then we can do volume equals base area times height. Our base area is 24. And then our height, now the height is what's perpendicular to the bases. And so drawing it this way makes it easy to figure out that the height is 5. When it's sitting like this, it's hard to tell which one is the base, so you need to recognize that it has to be the 5 because that's what's perpendicular to the two parallel triangles. And so the height is 5, and so then 24 times 5 is 120, and that's going to be in cubic feet. That one didn't need to be rounded because it's already exact. We didn't have pi in our answer for this one because there are no circles. Okay, so whenever you're ready, go ahead and try, go ahead and press pause and then try problems C and D. Okay, so for problem C, we have a cylinder. Volume again is base area times height. In this case, we're given the diameter is 24, so that means the radius would have to be 12 meters. And so the base area is going to be 144 pi, because it's pi times the radius squared. 12 squared is 144. And then our height is 8. And so now we have 144 times 8 is 1152. So we have 1152 pi cubic meters. And that is approximately 3619.1 cubic meters. So again, I want both answers, the exact and the approximation. For problem D, this is a composite figure, so it's broken up into two simpler figures that we'll put together. And so first we have the rectangular prism. So I'll outline that in blue. So we find the volume of that prism. So the volume of the solid is equal to the volume of the prism plus the volume of the half cylinder. Okay, so the prism has a base area of, let's see, this is 6 times 22. That's our base area. And then our height is 10. Six times 22 times 10 is 1320. Okay, and now we're ready to find the volume of the half cylinder. Since this distance is 10, our radius would be half of that, would be 5. So so imagine we have a cylinder with a radius of 5 and the height is 10. I'm sorry, the radius is not 5. The radius is half of 6, which is 3. So radius is 3 and the height is 10. And so the volume of the cylinder, of the whole cylinder, would be 9 pi, that's our base area, times the height 10, so that's 90 pi. And we're only taking half of that because the end of this composite figure is just half of a cylinder. So if we imagine cutting this figure in half and only taking half of the cylinder, then we would have half of 90 is 45 pi. Okay, and that's in cubic feet. So there's our exact answer. We can also approximate that, putting that into the calculator. 1320 plus 45 pi. Is about 1461.4 cubic feet. And we've got one more problem left to go. Go ahead and draw a sketch of this figure. It's a cylinder, a large cylinder with a small cylinder cut out of the middle. So you can imagine this is an open area in here, so it's hollow on the inside. So we start with one big cylinder and then we cut out the cylinder that's on the inside. So to find the volume, you're basically going to find the volume of the large cylinder and then subtract the volume of the small cylinder. Okay, so go ahead and press pause on your video, see if you can find the volume of this composite figure, and then press play when you're ready to finish up. The radius of the large cylinder is 5 plus 2, so that's 7. And so the base area for that one is going to be 49 pi times the height, which is 8. And then the small cylinder is has a radius of 5, so its base area is 25 pi times its height, also 8. So we have base area times height, base area times height. And we're going to subtract the 2 because the small cylinder is missing. That's why there's a hole right through the middle. And so now we have 49 times 8 is 392. So 392 pi minus 200 pi, that would be 192 pi, or about 603.2. And that's in cubic centimeters. Okay, so that completes today's video lesson. Go back and try any of those problems again for extra practice, or rewind and go rewatch any parts that you need to watch again. As you try the homework, you may realize you need to come back and watch some of this over again. All right, take care. Good luck.